In this video, we'll go over the Audio tab of System Hardware. I'll be using an RME Fireface UCX with Windows 7. For audio interfaces that Listen has verified, we'll look at the hardware compatibility list. The first column is a list of audio interfaces that have been tested, and the operating systems and drivers they are compatible with. Here on the next page, I'll now look at what driver is approved with my device. For Fireface UCX USB under Windows, the approved driver is 1.069. This might not be the most up-to-date driver by the manufacturer, but it's the most recent version that Listen has verified. This driver has been installed on my computer, and the device itself is ready to go. When SoundCheck is first open, you'll see this setup wizard appear. There's a couple options on the left side. We'll be looking at Setup New Hardware. The wizard automatically detects any Listen-approved hardware that is plugged into your computer. You can see that SoundCheck automatically identifies the number of inputs and outputs. It also plugs in some stock VP values and latency values. These values can actually be different even on channels on the same exact device. However, we've gone through and found, for example, that input 1 on the Fireface is around 12.74, so we include that as our stock value. In this window, you can use your Listen calibration sheet that was supplied with your interface and manually plug in every value. You can also just hit apply and use the default values. For now, I'm just going to hit apply and use the default values. You can see the settings are applied, and I can make more adjustments in the Setup Hardware window. Inputs 1 through 8 and outputs 1 through 8 now show up in our System Hardware Audio tab. Our VP and latency values are also copied over from that window. Here's the calibration datasheet that shipped with this specific UCX. You can see at the top it has the serial number, what setting it's used on, which is +4 dBu, and at the bottom you can see the latency is for a buffer of 1024. These are some settings that might be adjustable per device, and if they're changed on your device, these values will need to be recalibrated. So I went ahead and plugged in all of these values in, so you can see the VP values now match the more specific input and output VPs that were on my calibration sheet. These new VPs are close to the stock values, but they're measured out to a much higher degree of precision. At the bottom of the Audio tab in System Hardware, there are 4 options: Import, Save, Save As, and Cancel. Save will just save the settings and close the Hardware tab. Cancel will cancel without actually saving your changes and close the Hardware tab. If we click Save As, we can actually save a copy of how our system is set up right now. Because I've actually gone through and plugged in these exact VP values, I'd recommend making a Save As backup of your system hardware. You can see a file already existing called system.har. This is what SoundCheck is currently using for its hardware file. I'm going to save a copy, and I'll just name it the date, so 4/27/16, and hit OK. If I upgraded to a new version of SoundCheck, I could import an old version of my hardware file, so I wouldn't have to go through and make additional changes. Or, if I was using the same device on multiple computers, I could send this hardware file and import it to make sure my settings are exactly the same. So when I now click Import, you can see the new file that I just created. You'll also notice that there's 3 folders up top, called Windows 7, 8, and XP. These contain some stock values of devices that ship with SoundCheck. This is similar to the Setup wizard where I detected new hardware, but I can actually go in and choose an operating system and choose a device, and it will automatically fill in the input and output channels as well as some stock values that are appropriate for the device. I'm using a Fireface UCX via USB, so I'll select this and hit OK to import the settings. All of these hardware files use channel names of input 1 through X and output 1 through X. If they already exist in your hardware table, importing them can overwrite what you already have. SoundCheck warns you about this, and you can say yes to specific ones, or yes to all, or no to all. I'm just going to select yes for all. You can see it overwrites all of my calibration datasheet VP values and replaces them with the stock values. Here's an example of when you'd want to import something as well. My settings got changed in a way I didn't want to. I can just import my copy that I made, and it will overwrite it using my exact values from my sheet. Whenever system hardware is saved, it saves all three tabs: audio, listen hardware, and external. However, when I import, it gives me an option to only import the tabs that I'm interested in. When I'm importing this, I don't care about my listen hardware information. I'm just going to select audio. This will only change my Fireface UCX input and output channels. Again, I'll click yes to all to exactly what I had before. Now let's go over the specific columns in the audio tab. The first column is input name. By default, these are set as input 1 and output 1, numbered in ascending order. These can be manually adjusted, however. For example, I could just change my name of input 1 to Fireface 1. The second column is driver. Drivers that are compatible with SoundCheck are WDM, which is Windows OS based, Core, which is Mac OS based, ASIO, and NI-DAC-MX, which is a National Instruments driver. Device is what device I'm actually using. The device column is actually dependent on the driver column, so if I select WDM, you will only see WDM devices in the dropdown, and if I select ASIO, you will only see ASIO devices in the dropdown. Channel select is dependent on what device you have selected. So when configuring system hardware, the best way to approach it is to first select your driver, your device, and then your channel. Here, when this channel is selected, you can see in the dropdown all channels that are recognized by the ASIO driver on the Fireface UCX. A/D will let you select if the signal is analog or digital. Sampling rate allows you to select the sampling rate you are using on your device. Alias frequency is simply the highest frequency available dependent on your sampling rate. Bit depth will allow you to select any bit depth available on your device, which is user-defined. And latency is the delay in samples between the output and input of the device. Term config, coupling, and IEPE are specific only to NI-DAC-MX devices. The output channels have the same configurations except for latency, coupling, and IEPE. Latency affects both the input and output channels, so we just chose it to be reflected only in the input channel. Coupling and IEPE are only relevant on input channels. There are also some right-click options available in the Audio tab. Here I'll right-click on Input 1 and select Add Channel. This will open a prompt for me to name it something. I'm just going to choose Input 9. I can also right-click a channel and delete it. So I want to get rid of the Input 9 I just created, so I'll right-click and choose Delete Channel. If you're making adjustments to these channels, you can Control-click, Shift-click, and then if you change one setting, it will change for all highlighted channels. Another option is Duplicate Channel. This creates a new input channel, which is named -copy. So now I could just go through and make these inputs 9 through 16 or whatever I wanted to call them. You can also rename by double-clicking in the channel name field. The next option is Calibrate Using. In the next video, I'll go over calibrating a UCX I purchased without a calibration sheet, and that will be done using this Calibrate Using right-click option. The last option is the ASIO control panel. That is only available on devices with an ASIO driver, and that will just open on the computer the control panel. So if we clicked on this, it would open up the RME control panel. This ASIO control panel is entirely third-party dependent on what ASIO device you are using. It can be read by SoundCheck and communicated to with SoundCheck, but each of these control panels is dependent on the driver in use for the device. You can see if I change the sampling rate in SoundCheck, it's reflected in the control panel. Once you have your audio interface set up, it is recommended that you run a calibration sequence that comes with SoundCheck called self-test. It can be found by going to File, Open, Sequences, Calibration, Self-Test. Once this is loaded, I'll run it. It begins with a message step telling you to connect your left and your right inputs to your left and your right outputs. By default, these will be your input channel 1 to output channel 1 and input channel 2 to output channel 2. Make sure that no amplifier is connected. This is just an audio interface test. So I've connected them by a 1/4-inch cable. I'll click enter and the test will run. You can see that everything is passed. One thing to note is that if I was using a WDM or core audio driver, the sound card delay could fail, and the test itself would pass. This is because latencies used with WDM are wide and varying, and aren't exactly repeatable the way that ASIO or NI DAC-MX are. But the rest of these settings show that my frequency response, my distortion, and my self-noise are well within range to use with SoundCheck.